Good afternoon, everyone. Myself, Mehraj Fatima from East West College of Engineering, pursuing electronics in Department Communication from and my technical seminar topic is on 3D audio and acoustic environmental modeling. Before going to that, let us know about the introduction, literature survey, methodology, components, advantages, expected outcome, conclusion, reference. The abstract. In this abstract, the 3D audio technology is intended for the desktop computers. Many sound cards, multimedia speakers, video games, audio softwares, and CD-ROMs are marked as having some sort of 3D capabilities. A new technology called as acoustic environmental modeling has emerged, which combines basic 3D technologies with reverberation and other effects for natural acoustic scenes. In introduction, the 3D technology is intended for the desktop computers. Many sound cards, multimedia speakers, video games, audio software, and CD-ROMs are marked as having some sort of 3D capabilities. In addition, a new technology called as acoustic environmental modeling has emerged, which combines basic 3D technologies with reverberation and other effects in order to simulate natural acoustic scenes. 3D audio system has the ability to position sounds all around the listeners. The sounds are actually created by the loudspeakers, but the listener perception to the sound comes from the arbitrary points of the space. Conventional stereo system generally cannot position the sounds to the sides or rear of the listeners, nor above or below the listeners. Example: stereo multimedia speakers are marked as having 3D technologies. These speakers incorporate a simple circuit that has effect widening the precise sound field stereo recording. Let us know about how this 3D audio works. The sound generated in the space creates a sound wave that propagates to the ear of the listener. When the sound is to the left of the listener, the sound reaches the left ear before the right ear, and thus right ear signal is delayed with respect to the left ear. The right ear signal will be authenticated before shadowing the heads. Both ear signals are also subject to complicated filtering process caused by acoustic interaction of the trousers head and in particular pinna. Transformation of the sound from point into space to the ear canal can be measured accurately. A measure of the signal is placed on a loudspeaker and recorded by the microphones. The recorded signals are then processed by the computer derived by the HRTFs. The process of the diagrammatically, that is dummy heads with a microphone in the ears and two HRTF right and left in a speaker. This process is called as binaural synthesis. Binaural synthesis works extremely well to the listener's own HRFTs are used to synthesize localization cues. This is placed when sound signal is processed by digital filter and listener to over headphones. Let us know about how this 3D audio works over the loudspeakers. When reducing the localized cues, the listener is important to that left ear of the audio remains separated and left ear signal should go to the listener of the left and right ear should go to the listener of the right. Where using the loudspeaker, however, the signal crosstalk between each speaker and the opposite ear of the listeners. Acoustic environmental modeling refers to combination of 3D spatial location cues with distance motion, ambience cues to create a complete simultaneous of the acoustic scenes. By simultaneously acoustic interactions that occur in the natural world that achieve stunning realistic recreations and beyond the possible with just. The wave arts acoustic environmental modeling combines the wave arts 3D accurate simultaneously the following acoustic phenomenon: reverberation, distance cues, Doppler effect, and then air absorption and object occlusions. Reverberation. When an object in the room produces sound, a sound wave expands outwards from the source reaching the wall and other objects where the sound energy in both are absorbed and reflected. Reverberation contains a lot of frequency energy within the decay associated with rooms that have hard reflective walls which do not readily absorb high frequencies. In acoustic environmental modeling, reverberation often simultaneously by considering a simple geometric model of simulated space. Reverberation is essential for establishing the spatial content of an auditory scene. Reverberation gives information about the size and character of the surrounding space. It is very useful for correctly precise distance and it adds greatly realism of the simulations. Each reflection can be rendered using the delay line to delay sound according to the total travel time reflected path, or attenuated or filtered to approximate transmission and reflected losses synthesized to properly spatialize the reflection. Hence, the principal cues for the distance of the loudspeaker of the sound. A sound source will be louder when it closer to the listener than the farther away. When the sound is produced reverberant space, the associated reverberance may often be precise to the background ambience. The relationship between the direct and the reverberant sound is shown in the figure. Doppler effect. Doppler effect is commonly heard in the nature as a pitch change when speeding object passes a listener. When an object is approaching a listener, the pitch is higher than this, resulting the pitch of the object. Air absorption. When sound propagates through air, some sound energy is absorbed in an air itself. The amount of the energy lost depends on the frequency of the sound and atmospheric conditions. High frequencies are readily more absorbed and low frequencies are reduced with increasing distance. Object occlusion. When the sound source is behind an occluding object, the direct path sound must refract around occluding object to reach the listener. Low frequencies with a wavelength larger than the size of occluding object will not be affected by occluding object. High frequencies with a wavelength smaller than the size of the occluding object will be shadowed by the object and will be greatly attenuated. The signal routing includes inputs from the one to the input to the n. Input is given to the Doppler. Doppler is given to the air absorption and modulation. Then 3D cues. This includes reverberation gain and direct gain. The input from the reverberation and gain and direct gain is passed to reverberant mix. Reverberant mix. This includes post EQ to the headphones outputs and then crosstalk to crosstalk EQ and post EQ signal output. The signal routing is conceptually similar to routing seen by the multi-channel, mixing the input signals are individually processed and mixed a set of shared signal buses, and then bus signals are processed and output. Each input signal is processed to the Doppler effect. The 3D spatial effect is controlled by the position of the sound effects relative to the listener. The output of the 3D spatial processor is split into the two stereo signals, which are mixed into reverberous and direct bus of the stereo bus. The virtual speakers includes delay filtering 3D cues to the direct bus. The wave arch of 3D audio system provides a special type of sound object called as virtual speaker, are intended to simplify management of virtual surround processing. Here, virtual speakers are like stationary sound object. It is fixed space and assigns like a sound. Unlike stationary sound objects, however, virtual speakers are not subject to environmental effects. Virtual speakers that produce only certain frequency ranges of the input sound. These virtual speakers can be positioned anywhere around the listeners. It is easy to create pseudo sounds from the mixers from the conventional inputs. This can be done assigning the left channel input to virtual left speaker position and the right to the right channel speaker. Virtual speaker, it is easy to convert the conventional stereo sound into an immersed 3D sound. The channel assigned virtual speaker. Virtual speaker can also be assigned directly to the output channels. In this case, virtual speaker location is not synthesized by applying 3D spatial cues. Instead, input sound is routed directly into the stereo output channels. The virtual speakers are usually mixing original stereo program material into 3D scenes. Virtual speaker can be directly assigned to left or right on the center channels. Thank you. Hence I conclude 3D audio and acoustic environment.